Okay. Thank you. If you could do that every few slides, just to like. My name is Michelle Sandford. You can connect to me on all of the socials there. Especially LinkedIn, I would say connect, don't just follow, because after all, we have been together in this conference. We are best friends now, we are not followers. I do also have these little things, which are NFC chip business cards that you can come and collect afterwards. You scan it with your phone and it takes you to my socials, but you can rewrite those with your own socials after you have scanned mine using the NFC Tools app on your phone. So then you can have your own little badge to wear at conferences instead of carrying around physical cards. And some stickers and stuff. Cool. Oh yeah, that's what they look like in case you can't see them because they're too small down here. Cool. So, what is the trolley problem? How many people know this? Oh, really? So, less than half know what it is, and yet you are here. This is marvelous. There is a show that you can watch on Netflix called The Good Place. Has anyone seen that? So there is one particular episode on the trolley problem, which is startling, shall we say. But it's a really, really good episode and worth watching if you become interested in it after seeing this presentation. So it is a thought experiment in ethics. I did philosophy as my undergraduate degree many years ago. So I was always very interested in this from the first moment I heard about it. What it is, let's say you are one of those guys working at a train station, and you can see the tracks in front of you, and one of the track is closed for roadworks and the other one is open. However, as you're looking down on the track, you see that a nefarious kidnapper has tied 5 people to the track. And if the train continues along that track, it will kill those 5 people. However, if you shift it to the other track, it will only kill the one worker that is working on that closed track. He has his headphones on and he's working away because he knew that the track was closed, so he is not expecting any train, he is not looking in that direction. You have the power to pull that lever and shift the train to the other track. How many people are pulling that lever? There's no one pulling it? Not? Five people are going to die if you don't pull the lever. You're not going to pull it, you'll pull it. You will save the 5 and kill the 1. Well, that is true. He's committing an active action that will cause the death of that one person. And if he didn't do anything, then actively there are no deaths on his hands. However, what about your consciences? You have let 5 people die. You could have saved them. You are all worse than this guy. Do you feel it in your hearts? Any guilt? No? No? Okay. The rooms are normally more split on that. In fact, a lot of people normally say they will take the active action to save 5 people. What if they were your children? If they were your children and this was a stranger, are you saving your children? Yeah? Okay. What if the guy, like these are all strangers still, but the guy on this track is like a pretty evil man? How did you know? Well, you know him because he's working there every day. He kicks you as he goes past your little thing. Yeah, so, okay. There are a lot of variations on the trolley problem. So, of course, I didn't mean the kind of trolley that I first showed. I mean more this kind of trolley. And so what we are doing here is we are pitting the idea of the measurement of good by an end result against the measurement of good by the actions that you take. So utilitarianism is the philosophy that says that what is important is the greatest happiness of the greatest number. So you will always do what will impact more people and create more good for the world. So saving 5, sacrificing 1 is a very utilitarian viewpoint. Deontologicalism is thinking about the actions and assigning them value in and of themselves. So taking the action to pull the lever and causing the death of that person, you don't want to be the active participant. So it's saying the action is in and of itself wrong to do that. But then, of course, with philosophy, you can always go deeper. So then there are the people that say taking no action is not an excuse. Taking no action is in and of itself a choice. And you chose to let those 5 people die by your lack of action, and therefore you are not any morally better because you didn't actively do it. So these are things to think about, I guess. Philippa Foot is first credited with introducing this idea, and Judith Thompson from MIT coined the term. Oh, we do have one more scenario that I think is interesting. Let's say that you're not co-workers with the guy that's on the track. Let's say you're just a observer. You're standing on a bridge over the track, and you see the train coming, and there are 5 people on the line, and you are standing next to a big fat man. You could push him off the bridge and he would stop I shouldn't laugh when I'm saying, oh, I'm talking about murder. Push him onto the line and he will block the train. Is anyone pushing the man? But, I mean, numbers-wise, it's the same, But, of course, no one in here, apart from this guy, was actually willing to be active. Would you push? It will stop the train. This is a man that is thinking decisively about his actions. You could be all more like this man. You're not fat enough. If you jumped off onto the track, you're not stopping the train. You need someone bigger. Yeah. Okay, how many people are going to throw themselves? Let's assume you are big enough, or whatever you can sacrifice yourself to save the 5, but they are strangers. How many people are doing that one? No one's into that either. You're right. Yes. People are definitely more likely to jump in and save other people, especially if they think they are not going to die. However, that's no fun, is it? We have that. This is what we call the trolley problem of the skies. This is a AI-generated image of the Predator drone, which has forever changed the way that we do warfare. So the United States started using these in the 1990s, and on the one hand, it's a marvelous thing. They are taking their people out of direct fire. They are saving the lives of the boys that they are sending to war. However, they are absolutely abstracting themselves from that warfare, and there are many civilians that have been killed by Predator drones because, it's so far away from the people that are actually doing the killing, and the people that are doing that are not even seeing the faces of the people that they are killing. I'm not sure on the statistics because, of course, the US is not keen to reveal whether it is tens, whether it is hundreds, or whether it is thousands or tens of thousands. But it has been hotly debated since these were introduced as to whether this is an ethical way to do warfare. So now, what is the modern trolley problem? So what I am talking about today is the trolley problem in the context of autonomous vehicles. So whenever you have self-driving cars, there is always a debate around whether you trust the car, or if the car is in an accident, whose fault was that? Whose fault is it generally if there is a fault with a self-driving car? Or if there is an accident, a critical accident with a self-driving car? Most commonly, who is at fault? Huh? So she thinks the person that trains the model, you think the car, and you think the tester. The suit that wants to release it before it's ready. So the magnificent CEO of I do talk about them in a little bit. Yes. Well, generally, actually, when there is an accident, it is the driver's fault. The person sitting behind the wheel, whether they are actively driving or not, that is what the law currently says, that none of those vehicles are responsible, none of those people are responsible. It is the person behind the wheel should have been paying attention and intervened. In America, they do have some really autonomous vehicles, taxis, where there is no one sitting behind the wheel at all. In that case, yes, it is going to definitely be somewhere else that the fault is assigned. But yeah, we will see. We'll discuss it as we go on. So, in an unavoidable crash situation, though, what do we tell the car to do? If we are the programmer, what do we tell the car to do? What do the autonomous vehicles do when they do not know what to do? Huh? What was that up there? He said stop. Save the driver. Save the driver. I wonder what that code looks like. I do have that on a slide a little bit further on. Generally, it is stop. Generally, when the cars do not know what to do, they stop. I do have some. This is an interesting one, actually. Yeah, I found this video on the internet. This is the driver, the person who was behind the wheel of a Tesla when it killed a pedestrian on the roads. Now, he wasn't driving, the car was driving. However, Tesla does say that they require an active driver in the driving seat, and so therefore it is not their fault. What is interesting about what the findings in the report said was the emergency autonomous braking is turned off in these cars when the car is driving. So if the person is driving, autonomous emergency braking is turned on so that the car can intervene if the driver does something wrong. But if the car is driving, emergency braking is turned off because the cars have been behaving too erratically and the emergency braking is causing problems. So they turn it off when the car is driving itself. And what happens in the case where a pedestrian walks out in front of the vehicle is the car immediately, it expects the driver to intervene, but it does not alert him to the fact that there is someone in front of the car. So the car saw 6 seconds out that there was a pedestrian there. it didn't do anything because emergency braking was disabled. It basically looked to the driver, but without saying look to the driver. The driver was looking down, I think, at his phone. And when he looked up and saw it 1 second out from impact, that was too late to respond for a human, and he responded 1 second after impact. So that is very interesting in that the current regulations make it such that the manufacturer is reluctant to implement extreme safety measures. The less risky thing for them is to say, we turn it all off and the driver must take over when something drastic happens. And then the driver is always at fault, pretty much, unless there's a hardware failure. So that's a very interesting scenario. This is not going to continue to work. The UK, for instance, is going with the reverse. They're going to implement legislation that says the manufacturer is always responsible, unless proven otherwise. And I think that that will force the car manufacturers to implement stricter safety controls. So, but philosophically, we're talking. So, who do I save? Is the value of one person more than another? In some countries, for example, so say you're talking about where you said it was the programmer. How do you program that? In some countries, they would definitely say the life of the driver should be valued above all else. But in other countries, they might say the elderly are to be revered, and so therefore, if it is an old person and a baby in the road, then save the old person. In other countries, the opposite. If there's an old person and a baby, save the baby. The potential, the wisdom. You have those two things against each other. In India? Yeah, exactly. We should value God above all else, for sure. Save. Yeah, exactly. And so is the programming in the cars to be different country by country? Is there to be, so if you're buying something that is a global brand, should it be that the at each country as it is imported or before it is sold, it is released with a cultural update in order to control how the car will behave on those roads? I mean, currently none of that is there, right? Currently, in the case that the car does not know what to do, it simply slows down or stops. But yeah, preserve my life. There are plenty of countries where this is the individual comes first, and you would value the driver above all else, except, so if we're thinking about America maybe, except in the case where you're going to be sued by the people that you mowed down and you are poor, in which case the value is of the richest person, surely. This is a real picture. What should we do here? What should we do here? This is very common. This is a very famous piece of track, and people are always going there to take their Instagram photos. But that must be very cumbersome for the train trying to come down the tracks. Is the train responsible if it hits someone in this scenario? And I guess what we are really skirting around is, can the autonomous car really be expected to take into account people's intentions? So here, people's intentions to take photos, this is frivolous activity. Maybe it should be programmed to speed up. But anyway, we get to it. What is a self-driving car? Does anyone know the definitions of all of that? Yeah, there are. few levels, 5 levels, yeah. But I guess basically what we want to say is the car needs to be able to go from this point to that point on its own without, manual hard coding in its programming. It needs to be aware of its environment, of the people, of the roads, of the things around it. It needs to make accurate decisions based on what happens to it in the world around it, and it needs to arrive safely at its destination. There was a lot of stuff that came out last year about the video on the Tesla website, saying that video showing the car driving around autonomously on its own was not was a marketing video, that the car was hard-coded to drive from its initial location to its end location, that it did not do that without incident, that it did hit various things on the way, the fence on the way out, things like that, but the video remained on the website at least up until last year. I didn't check it just now to see if that is still there, but that is a very interesting way to go when your engineers have come out and said that the video is not a real thing. But what we all want to know really is, when can we take the driver out of the car? They are definitely doing this already in America. So they have Waymo vehicles in San Francisco and in some other states where they are driving around the city, and you can see videos on the internet of people sitting in the back seat showing, what is happening as they drive around the city. So it's not going on private roads, it's not going on closed roads, it's going around, and mostly it's okay. I would say that probably, if you look at the statistics, it is very okay. It is much less dangerous than the statistics of actual drivers crashing into each other on the roads. But of course, people are less interested in those stories. What we really need, I guess, before we can take the driver out of the car, is that technology must advance to a level of safety and security that people can, believe it. People really feel that this is a thing to be trusted. This is another somewhat hilarious meme on the internet right now. That's a Waymo car. I don't know, can you read that okay? The cone is saying, Waymo, my old nemesis, we meet again, but this time the advantage is mine. What this is in reference to is the fact that people are rebelling against the Waymo taxis on the roads in San Francisco by locating traffic cones, picking them up, and putting them on the bonnet of any Waymos they find. The Waymo then immediately stops and puts its hazard lights on, and it is unable to move from that situation. And so this has become a tremendous game for them, and it's very effective. And there's also, this is taken from another video where no one was doing anything nefarious. There was just a YouTuber in the backseat videoing what happened, and the car came onto a road that had cones on the road, and it was somewhat perplexed by them. So initially it stopped, which is the good thing to do, but that stopping did interfere with traffic. Then after a while, so roadside assist is supposed to come, so 6 minutes they would come, but the Waymo was smart enough to figure out that these cones were stationary and not really a danger to it. It could see what other cars were doing, and so actually it then pulled off before the roadside assist came, and it turned around the corner, but then it saw a lot more cones, and it was perplexed again, so it stopped in a much bigger road. Yeah. I think you're very right. If we took humans out of the picture, the world would be much better. Yeah. Yeah, yes, I understand that you're not saying it to that extreme, but I absolutely am on video. Yeah, yeah, I think in many situations we are the troublemakers. We are absolutely the ones that are creating the incidents and the accidents, and the world would be a simpler place without us. However, those Waymo protesters disagree with me vehemently, which is why they are trying to interfere with the trial of those Waymo cars. But they're also in much wider open spaces. So, for example, we do have autonomous vehicles in Western Australia where we are, up in the mine sites. There are a lot less people and there is a lot wider space. We do have we have had an autonomous bus going around in Sandford for many years now, but it has a fixed route that is agreed by the city and it has a driver that monitors it at all times. So currently, yeah, there is too much randomness in the world and not enough legislation to make clear, to make it obvious that the manufacturers should work harder to make things safer. So, the fix for those Teslas should not be to turn off the emergency braking. That should not be. So, I work for Microsoft and we take responsible AI very seriously. We can do a lot with AI and it's really incredible, but not if it is used badly. If it is not used responsibly, if it's not used ethically, then very bad things, very unsafe things can happen and you can do great harm. This is one of my favorite slides. Now, I got my master's in computing science many years ago. And in fact, I would say in 1956, this was not when I got my degree. In 1956 was when AI started. And in 1997 was when machine learning was introduced. I got my degree before machine learning was introduced. So every line of code that I was writing for AI, I wrote myself. The machines were not helping me at all. And that was very hard. But also what I did was not very complex at all because it was all me and my brain is not very complex. But, the Turing test back then, we all know what the Turing test is. Yes, good. Turing test, can the program, can the machine fool human into thinking it might be a human? And so Eliza was like a little counseling one, and she would just say, you'd say, "Hi, I don't feel good today," and she'd say, "Oh, don't you feel good today? Why don't you tell me about that?" And then you'd say, "I'm angry with my mother," and she'd say, "Why don't you tell me about that?" And that was it was a pretty good trick into making people think it could be human, but not very convincing if you talk to her for a long time. But now, with generative AI, with ChatGPT, I think it could absolutely pass that very easy Turing test now, today. But that doesn't mean that it's conscious. That doesn't mean that it's real. It doesn't mean that it's alive. It also doesn't mean that it's not, because whenever I compare the AI to the things that I could do, I think that it does things better, or it does things in the same way that I would do. For example, when it doesn't know what to do, it doesn't stop, it makes it up. Many of us do that, right? If someone says to you, "What do you know about this?" you would just say some blah 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 and probably be able to pass muster. So yeah, I don't think it's that different. Anyway, all of these years are when the technology reached human parity. So we have the technology to do all of these things, and yet AI systems go wrong. Where is the problem there? Does anyone want to guess? If we have human parity here, but things go wrong, it is because... Right, what humans? But is the machine not just doing it magically itself? Which particular humans? Right, the data, badly trained on bad, biased human data, badly tested, badly, maybe the data set wasn't big enough, maybe we were too cheap to do many training runs, maybe our code was bad. That's correct. We did used to talk about narrow AI and wide AI. And so, narrow AI is how it can do each of these things in isolation extremely well. But to replicate all the complexity of humanity, to put all those things together, there is so much room for things to go wrong. Yes, absolutely. Eli just said that if we as humans cannot agree on the meanings of words, on the ways that we interpret conversations, George and I are constantly arguing because he sees things in a different way than I see things, and then we are real mad at each other. Yes. No, I see them the right way. Okay. Yeah. I think we are lazy. I think that you know, we do not train thing. You'll see it when I show you my demo. You will see that I did very little training for my demo. You'll see that I didn't do like multiple runs because the cost goes up. And what we are always looking for is a way for us to do less, but also for us to not have any blame on ourselves. Microsoft, however, is better than me. Microsoft says use it responsibly or not at all. So the face service is one of the things that I really enjoyed. There were so many fun apps that people created using the face service. But even from 2020, there was this yellow notice on there saying that you can use it, but the US police force cannot use it. And the reason they could not use it is because they implemented AI lazily using this. They used it to identify people that it said were criminals, but because they had not trained enough data, it actually said that man committed the crime, and they then sent that man to jail. However, it was not well trained on people of color, and so for it, any black man was the black man. And if the police had done their job, they had checked his alibi, they would have seen he was in a different state at the time, he could not have done it. That would have been fine, but they didn't. They were lazy, and they just said, the black box says it, it must be true. So we took it away from the police and said, until you can build stuff responsibly, you cannot play with your toys. But then in 2020, what are we in now? We're in 2023 now? In 2022, they also took it away from everyone, and they said, you can use it. You can absolutely use it, but you need to put in a use case and say how you are going to use it responsibly and how you are going to show that, it will be well done. Yeah. That's correct. As we discussed earlier, country by country, culture by culture, People might have different views about what is right and what is wrong. Um, yeah, this has definitely made me more of a chaotic, neutral character because thinking of all those things in philosophy, it definitely mixes up your what is there such a thing as light or dark or right or wrong or truth or falsehood. It all depends on your perspective. Are you looking from inside the house to outside the window or outside the house to inside the window? Where you stand has a lot to where you stand in the world has a lot to say with how you view things. Absolutely. I am very good at moving off the point, but I will just say very quickly, does anyone remember Tay? So Tay was a chatbot that Microsoft created way back in the day, and we had it training in China, I think, for over a year, and it was fine in China, because in China they are very well behaved and very polite, and so Tay was also well behaved and very polite. And then they said, well, this is good. China, massive market. She has done well there. Let's release it to the world. Within 24 hours of Tay on the internet, that poor child chatbot had been corrupted by bad people. And she was swearing. She was extremely racist. She was visiting the darkest conversations and repeating that stuff back. And her mother, Cortana, and her dad, Bing, had to take her off the internet and send her away to a Christian camp for reevaluation. We have never seen Tay ever again, which is such a shame because she was such a good child. So yes, China can be the good one, and us in the Western world, the evil freedom of speeches. So here are the responsible AI principles that Microsoft has. Ideally, it shouldn't be that the tech companies are the ones that are, instilling their morals on the world. You would like it to be governments, or at least organizations who are extracted with nothing in it for them. However, they have not been super keen to put their feet in that pool. So therefore, the tech companies have tried to put those guidelines up, and I think that these are really good ones. So there is a responsible AI website. I do have a link at the end, and it has like so many resources on there for you. So you can find the principles, you can find videos around it, you can find playbooks, you can find resources, checklists, all sorts of design documents, stuff so that you don't have to think of all of these things yourself. You can follow along and apply them to the product you are building or the company that you are growing without having to reinvent the wheel. If you don't like it, absolutely take what you like and use other stuff from elsewhere, but I would imagine that most people are going along the same guidelines. So I'm just going to real quick go through each of these things. Fairness. All AI systems should treat everyone fairly and avoid affecting similarly situated groups of people in different ways. So I like to give this example as, let's say you have a bank, and the bank manager says he will only grant loans to white men. This is not fair, and everyone can see that this is not fair, right? The way that you should grant loans is based on how much money they want to borrow. Are they earning enough money to make the repayments on the back, and do they have any history of not making payments? I would say those are the only things. Whether you are, what color you are, what gender you are, what age you are, all of those things I think should probably not have much impact on your loan. So be fair when you build your stuff. There was a tendency in the past for people to gather data, all of the data, and if you allow your machine learning to have access to all of that data, it will make judgments based on that historical data, and it will make assumptions that are probably not correct. So in the past, mostly men took out loans, and therefore it will assume that men are good people to give loans to and women are not, because that's the data that it's running on. So try to take out the stuff that should not be relevant to what you need. Which way do I swerve here? Obviously, away from the dog. Reliability and safety. So this is about AI systems should operate reliably, safely, and consistently under normal circumstances and unexpected conditions. So this is all about your testing, this is all about your deployment, this is about giving you updates and not charging you for those updates. It's been a big issue in technology from the first days of the automobile, and the creation of the car led to a number of safety standards that helped improve the safety of drivers today. So we need to take that principle further forward as we move into more AI. Does anyone recognize these? Exactly, Asimov's laws of robotics, which if you reread those books now, has anyone done that, read those again recently? They do not really hold up super well. But if you take out all of the, take your mind out of all of the sexism and the smoking and stuff like that, it's the stories are fantastic, and these laws do hold up super well. I think that you can apply these laws to life. These are laws I think that we should apply to how we interact with each other, not just how machines should interact with us. So this is a thing that I always think of when I drive to the airport at 3 a.m. in the morning and it is raining and there are roadworks on the road and the light is shining into my car, and because it's 3 a.m. I have forgotten my glasses. I think I would be very happy for an autonomous vehicle to be driving me as opposed to me. I think it would have a much better chance of doing that safely because it is not tired, its eyes are not weak, it has multiple sensors around it. And yeah, it's not me. I'm not a bad driver, I should say, but 3 in the morning. And this is kind of how it sees things. It sees things in a pixel by pixel view, and not just a 1 pixel, but it's like a red, green, or can't even blue pixel grid. So it's seeing things in a level of detail that I definitely cannot see. These are some applications of computer vision. This is really one of my favorite slides. If you're using PowerPoint today, or I think Twitter does it as well, and you put an image in there, it will offer you some alt text for what it sees in the image. Didn't used to do that, right? A few years ago, you had to manually type the alt text, which no one did, which was very non-inclusive of us because we were lazy humans. But today the AI will help you with that. It will identify what is in the picture and it will try and label it for you, and it will try and say that out. Love that. Saves me a lot of time. That one is object detection. I have a little demo around that in a bit, and those things that you see around it are bounding boxes. I'd be a lot happier if instead of bounding boxes, it was semantic segmentation that you saw when you were using autonomous vehicles. But if you look at that Tesla video, it's bounding box for sure. There's a lot of gap around that car. It's not very precise. And when you see it in my demo, you can see that also, because I was lazy with my training, I didn't always make sure that the box completely covered the object. And, if that is a car that you're talking about, well, maybe it would run over people's toes if it's not that precise. Semantic segmentation is pixel by pixel identification of an object, and so therefore that is a lot better. This one, the face detection and recognition, that was really excellent, and you can absolutely still get it, but not as widely available as it was. You have to apply because people were not good. But there are so many great use cases. You can use that to identify children that are lost in crowds, people trafficking, all sorts of glorious things. But this one's really my favorite thing. That's OCR, optical character recognition. When I was a student, if I missed a class, I would have to borrow the handwritten notes of a fellow student and manually handwrite those out myself, unless I was rich, and then I could afford photocopy money, which I could not. Today, they just take a picture of the screen or they take a picture of the notes, they paste that into their Word or OneNote or whatever and right-click on it and say transfer text from image, and the notes are all there. Beautiful, flawless, easy, and free. What a wonderful world they have. So these are the machine learning algorithms that an autonomous vehicle is going to be using. So it's going to be looking at object detection, object recognition, localization, movement prediction, semantic segmentation. I would hope that more come as they try to get better. But obviously, the more that you have, the more that adds complexity in there. But there is definitely a lot of technology there that can help them do an excellent job. And yes, compared to me, their sensors, their eyes, ears, radars, and all of that are a lot more than what I have. This is the little robot that I built. So what happened, there was an MVP in this country called Goran, who he built a Lego vehicle similar to this, and he put the instructions on his blog about how to do it, and I tried to follow those, and he had to help me a little bit more with the code because this technology is changing so quickly that it was already improving, and so there was more stuff to be done. But he did that, and that was great. But the Lego car, the problem is whenever it crashes into things, the Lego just falls apart. So it was more dangerous to the car than it was to the things it was crashing into. So I built it with this Meccano thing, and George helped me because the robots on the box, although very nice, they could not accommodate all of the technology we wanted to put in it. So in there is an Azure Percept device. There is a couple of Raspberry Pis in there as well. And so, like, you can see why the Lego couldn't cope with it, because there was a lot of technology it had to carry. But this was better. Okay, so here is that a video? No, that's not a video. This is just a little screenshot of the training that I did. So I trained it to recognize Lego cones and Lego men. And those are the confidence scores, but you see the bounding boxes are not like fully covering the devices. This is not a safe way to go into production. The reason why it is like that is because I didn't train it on many pictures. Let's have a little look at the demo. So yes, it's going. So this is how easy it is. You can just go straight into the studio there. And then you're just naming it. You are, I should be wearing my glasses and then I could see it better. You just name it. Doesn't really matter what you name it. You can, nice to pick a new resource for every project that you have. Object detection or classification, and domains. I just have general there. There's a bunch of domains already preloaded, so it can recognize the world around it by loading up those domains. For example, it can recognize tables, chairs, books, things like that in my room, based on which domain you install. This is me uploading the photos that I've taken of the cones for training. If you were doing that in production, obviously you would want thousands, hundreds of thousands maybe of things, maybe more than that. But obviously the more that you load, the more expensive that's going to be, the more training runs that you do. I did the minimum amount. So there are 15 images there. Very lazy, very cheap. But more lazy than that, because there is a minimum amount that you can do, which I think is 15, which after that, if you load any more up, it will try and self-identify. So you can load more and it will label them itself from those 15 that you have done. So really I was looking for what is the least amount of work I can do before the machine takes over and does it for me, which is fine if I even did those 15 very precisely, but not necessarily so. But you see, like, it's real easy to do. You just, like, you click on it, you label the cone, go to the next one, see, click, label, but I should have made the box bigger. I should have put the box fully around it, but I did not because I am lazy. And yes, I am human, he says kindly, because of course the rest of the room is not as lazy as me, and you're all judging me and saying, well, I would have done it properly. Yeah, exactly. Life is hard. Life is hard. You need to conserve your energy if you're going to survive it. There's the Lego man. Now, in fact, I didn't give it an instruction in the code as to what it should do with the Lego men. I only gave it an instruction that it should avoid Lego cones. So it doesn't know what it should do with the Lego men, but I really just thought there should be some people in here. So I'm really just trying to grab any extra images because not all of them were good enough images. And there we go. So you see you can add the extra tags to say it's a Lego man. At some point I decided I should have been putting Lego person, not Lego man, but it was it was too, oh yeah, there we go, Lego person. See, if I had just said the little chest, that person would have been doomed for sure. Theoretically, it's quite calming watching, like doing the training. So, but it could, yeah, very quickly become very tedious if it's your job and not the joy of Lego. Let's see. Let's skip ahead. Oops, that is not at all skipping ahead. But that is absolutely. Oh, what happened? Oh, yeah, there we go. Skip ahead. So there we go. So very quickly it will do the training very quickly because of the few images I've put in there. If you had hundreds of thousands of images, obviously it's going to take a bit longer. Are you playing? Yeah. There we go. That quickly. Is that good enough? Is that good enough? Look, she's like, no, Michelle, the Lego people will die. And so, yes, you see, you would put more images, a lot more images. You would do a lot more training. You would do them from different angles. You would do a lot of things in order to ensure the safety of the Lego people and more. Oh, look, see, those are even like sideways, upside down. There we go. Getting better? No, not really. Oh, group shots. I was really trying to, that's the smart labeler. So after you have a certain number of images, it will like do it for yourself. But I was really trying to do more without really doing much more work. There we go, suggested. Go person. In some situations, they might be lying down in the middle of the road. There we go. Look, better. Is that good enough for production? She's like, your Lego people. They will maybe look. It identifies them clearly. Okay, let's go. Let's go next. Privacy and security. This is protect private information and resist attacks. So this is super critical and complex. Over here, you guys all follow GDPR, right? Yes, and this is why whenever I open an internet page, I have like a massive thing reminding me of stuff which I don't read. In Australia, theoretically, we are not bound by that, but in Microsoft, we are a global company, and so therefore we tend to follow the most stringent regulations that there are. GDPR has made things very simple for us. I think a lot of the time Microsoft says to us, just do not gather the data at all. If you do not need it, do not ask for it because it is too much trouble. And arguing, I don't know if you've ever tried to argue with an internal privacy team. Do not. It will break your heart. This is a police car, Ford Falcon GTF, the most powerful police car ever. Here we go. I'm going to read this because this is the big list. Onboard tablet computer to check license status, outstanding warrants, photo ID, mobile fingerprint technology, front and rear cameras record non-stop footage to a fireproof, tamper-proof safe in the boot. 2 cameras can beam live images to the police operations room to monitor critical incidents. 3 automatic number plate recognition cameras can detect unregistered cars and cars likely to be driven by wanted or banned drivers day or night. Drug testing equipment, including the latest breath test units with GPS. Digital encrypted radio. Earlier police radio systems could have been heard by scanners, not these ones. Long-range radar that can detect speeding vehicles up to 1 kilometer away. So you know where you slam on your brakes when you see the camera or the police car? Too late, my friends. They already saw you before you saw them. Handheld laser units, also in case all of that wasn't enough. And complete 360-degree coverage. Yes. Where is the data? How long do they keep the data? These are all questions I do not know the answers to, but if I was working in the police force, these are things that I would be thinking about when building their platforms, because there's a lot of risk in holding that much data. Inclusiveness. For 1 billion people with disabilities around the world, AI technologies can be a game changer. They can improve everything from the way they see things, the way they do things. But when I say they, I of course mean we, because from the moment we are born to the moment we die, we are on this incredible spectrum that starts with us being completely unable to do anything and ends with us being almost completely unable to do everything. And in between, we have like this up where for about 5 minutes when you're like 22, you feel like you're invincible, and then after that everything starts to fail. You cannot see so well, it hurts when you get up from a chair, it hurts when you sit down in a chair. There are so many problems. When you build your systems inclusively, trying to think, what about people who cannot see things well or move well or do things with their fingers or do things with their hands, ultimately you are making things better for yourself, not just for them. Oh my goodness, look at the time. Hang on, I have to go way more quickly. Transparency, where I said the bank manager said he would only make loans to white men, he was being absolutely transparent when he said that. And so he is transparent, he is not fair. Transparency is really the most important thing because it instills trust. People want to know why. If the car crashes, they want to know why. If they are being picked out of a crowd, they want to know why. If you can say to them, these are the reasons, these are the parameters, they are less likely to be upset about that. I did want to just show you this little video of, oops, what has happened here? Oh yes, it's going. So this is what happened when I deployed the code to the Azure Percept. So see, it initially identifies books there in the bookcase. That's using the general domain knowledge that it already had loaded. Then I loaded the cones and the people men, Lego men on there. This is the telemetry that's being reported back from the robot to it. Now, can you see my little dog Leo in the background there? It's going towards them. It's told to avoid the cones. It's not told anything about the men. It has inadvertently identified Leo as a Lego man. And you can see the moment in his eyes where he realizes that perhaps he is being targeted by the machines. However, he is wily and he is able to avoid certain death. So that's a relief to everyone. Accountability. In that case, the person who wrote the code should be responsible. Who made the robot, who released it to the wild. I'm going to say that should be George. That is to blame, and I'll show you why in 2 seconds. Very quickly, that's the Tesla accident in the San Francisco bridge. The Tesla just pulled over for no reason and just stopped in a busy traffic, and then there was a pileup behind it. Tesla says, yes, Tesla has repeatedly said its advanced self-driving technology requires an active driver supervision, and they are not autonomous. Okay, who it could be? Training sets, that's the data scientists, hardware manufacturers, people who build it, the drivers, the pedestrians that leap out in front of you, the developers. Could have been any of them. That's some code. This is, my point here is just, when you write the code and when you use Azure, you can see the different things in either the web portal or in your code, depending on what you prefer. I prefer the code to the Azure portal. I do like this in that if you want to make your code explainable, you can now use GitHub Copilot Chat to explain the code for you. You can use it to write the docs for you. So it can absolutely explain what is going on, and it can write those docs. It can write some tests for you. All of the things that you hate to do as a developer, it will do for you now. You want to check it and make sure that what it's telling you is right, but it's all good. I did ask you if there was anything wrong with this code, because you see that commented out code there is code that George put in there with an instruction to kill the Lego men. The problem is, so it is commented out, and so theoretically he never told it to kill the Lego men or Leo. However, it did try and kill Leo, so would that stand up in court, I guess is the question. This is just the view of, what it did. And in fact, in this scenario, it did not kill either the Lego men or the cones. It successfully avoided all of them. Oh, no, go back. You do both. This one as well. And this one. Yes, so that was just to assure you that despite what it looked like, no Lego men, dogs, or cones were killed in the making of this presentation. There are a bunch of responsible AI standards and toolkits. I'll give you the links just now. This is a really good Twitter thing to follow, where he does ethics with Lego in order to help make you wise. Here are some good links that you can have. I will probably tweet out or put on my social media a link to the slides anyway, and then this is me. So come get some of these, and thank you for joining me today.